Okay, let's see. Alright, let's finish what I was doing. And so dynamic array.h. Yes, and then let's do the rest of them. So whoops, so print. I have no idea how to do that. No idea how to do that. Dynamic, so pop would be a good one. So this is T, this is token concat T, and this is DT. Yeah, I think that's fine. Then print, let's do that one as well. Which is again token concat this, then T, this is DT, and I'm guessing that we are gonna need to maybe do like const char format, like so. And this is actually going to need a format. Put s maybe. I think twist layout, so we can have a space in there as well, maybe. Let's include stdio. So yeah, I have the print, I have the pop, I have the push, I think I have the resize as well. I have resize, I don't have from yet. Let's just quickly do from. So just after new. This is DT, this is DT. This is token concat, and this is T, and this is T, and then token concat, this T, like so. This is just malloc, and memcopy is memcopy. Okay, so I think that's it, huh? I have everything I had for the ints. Except I need xmalloc and xrealloc. So let's try to build it. That works. 92. What is that? Sure. I don't know what that was. What was that? From. Yeah, okay. Who cares? And so the test will fail now. Or well, there is no test, so I think I need to do this, but before I need to define dynamic array type is an int, and so this is going to be an int. This is an int. I should. Alright, I'm just gonna add int manually everywhere. That's fine. That's fine. Yep. And this as well. This here, pop, and that one. Is that it? Yes, still passing. C-lang format, let's see. dynamic array dot h. Okay, there is still like compilation errors, but that's fine. That is quite fine. Okay. Can we do define din array new is this to make it slightly cleaner? Din array new. Does that still compile? Yes, that still compiles. And so here we can do dynamic array new. This one, I think it should still work. Okay, I'm just gonna do that for the one that I use it in multiple places. So I think resize is one of them. Define dynamic array resize is this dynamic array resize to make it slightly more readable. Okay, grow as well. I guess we don't really need, since grow is a static function, I could just have it there. Although if I want to expand it in the future, I think it will be handy to have grow. There. Define dynamic array grow. Grow like so. And so change it. No, grow like so. Where else am I using stuff? Nowhere, as far as I can understand. As far as I understand, I need to undefine those later. Up. Yes, no, that's good. Where else? So there is just resize and that's it. Okay. So undef to make sure the user doesn't accidentally use them. If undef let's do din array command includes I think that's maybe a good optimization, like will clang okay, clang removes it. Yeah, I don't know, to avoid like trying to include those files multiple times. I don't know. Does it matter really? Probably not. I think what we want though is to touch src utils dot ch like so maybe. Maybe. Or I just put it back into this. Yeah. So all the stuff that needs to be generic can be destroyed, but I would like to keep this thing. Yeah. Okay, fuck it. Let's just rename utils.c. Let's just touch Cersei utils.h. Don't need this. Let's not make it static. Let's do utils.h. If and if dynamic. Yeah, I don't know. How can I call it? Utils h, like so. Define and if, like so. Yeah, I don't know what a good convention to avoid name clashing is, but in my case, I don't think I care too much. Let's just have those here. Include std edit. Do same thing for him. And what we need then is this guy, and here we need to include utils.h, like so. Yeah, because this, we don't have this one anymore. We do have utils, no. We do have utils, yes, that works, it's working back, and then malloc is becoming xmalloc, this is xmalloc, and realloc is becoming xrealloc, and malloc, I don't need 2 instances of it. Okay, it's working back, and now we have like the memory management kind of thing. Not memory management, but like crash on error. Yeah. So maybe I should commit now, since the tests are working back, and yeah, the tests are working back. Yeah, this works as well, so yeah. Well, seems good. Git commit message. Update to generic header file. VG sign. Okay. Wonder what kind of improvement I could make. I mean, besides just adding a random function for the sake of it. Yeah, I don't know. Maybe I can just stop there. It was quite fun to experience with the like this kind of thing. I need to undef DT as well. Not really sure what to do next. I really wonder, like, I'm just curious about the generic thing. Didn't array, didn't array push will be just a DA and then some random number, and then generic that we would do. Can we do the generic on DA? I mean, we can do it on X, I guess. And then I forgot what it is. So it's this. And then we have, like, if it's an int, we do push int of DAX. Otherwise, if it's a float, we do push float of DAX. And doesn't that mean that we could just do this? Why doesn't that work? Build example. Passing argument 1 of dynamic push float from incompatible pointer type. Here missing. Yeah, okay, that's fine. Wait, let me have only one of those. Passing argument 1 of dynamic push float from incompatible pointer type. A definition of macro and dynamic array push. But it's not a float. It's an int. How about we do the generic thing on DA? So if it's a dynamic array int, I guess I can do pointer. Can't I do this? Expected specifier qualifier list before this. Not expected. Definition of macro din array push. But why is it a float? I don't get it. Why? That's not a float. What if I only have one of those? Expected specifier qualifier list. I'm confused. I am really confused. Isn't that what he wants? Like... Or maybe my compiler just doesn't have the correct arguments. Like, can I copy paste what his example is? Can I just do printf? Yeah, just d whatever type index of just this. Okay. That does not seem to work. Ah, yes, because char are integers. Okay, so that does work. And if we do dA is 0, what if I do din array is 4? Din array pointer? Okay, so it needs to be the pointer. Push then generic, which takes type, and so this needs to be a pointer. And then we do this. Expected a type. Expected line 10. Like what's different? What is different, my dude? Oh, okay. Ah, okay, I see. That's so dumb. That's so dumb. So I just need to remove the freaking thing. So can I just remove this, and then I can have my float thingy there. Can I have this? Can I have this? No, that doesn't work. Can't I put like a default of just assert 0, like so? Okay, just, I don't know. So it is going to the default case, which I don't understand why. So if I do just x and int, it is also going there. I don't really understand. Oops. How do you do FG? Yes. Oops. Passing argument 1 of type of dynamic array push float from incompatible pointer type. And if I just remove the push float, okay, then he's okay with it. Okay. I'm quite confused. Why? Why does all of a sudden he thinks it's a freaking float? Why do you think it is a freaking float? I don't know. But anyway, that's I understand more how it works now, the generic thing. But I still don't think it's very helpful since I mean I don't know. Maybe. Well, I don't know how I could dynamically generate a thing like this in the dynamic header array header. I mean, dynamic array header. And even if I could, I don't think I could generate one for new. But let's say that's not too important. Hmm. So strange. What if I do use the push here as well? So okay. So there is it's telling me that for the first one, for the integer dynamic array, it is using float, but for the of push in from incompatible pointer type. Oh. Oh, okay. Is it like evaluating eagerly the expression? Can I just do... Okay, let's remove the default. Let's remove the default and hope that it does an error, but can I do DAX here and actually remove the parentheses? Ah, okay, I see. And what if I just remove one? Does it actually error? Yeah, it does. Okay. So that's how we could do generics for at least push and like most of the stuff. It would be interesting to try, to be honest. How could I do this? So in the header, I could have like if and def dynamic array push. So we'll have a macro that is called dynamic array push. What about void pointers? Yeah, but void. Yeah. I already did a previous project like a few years ago about void pointers, but where I used void pointers to do this. But well, first of all, I just want to learn how to do generics in C in a cleaner way than void pointers, or in a different way at least. And also the very annoying thing with void pointers, if like I go in this struct and I replace whatever my type is by a void pointer, The thing that will happen is when I have to iterate over it, for example, I is inferior than length. I mean, yeah, obviously wrong code, but you can probably understand what I'm trying to do. And like I want to, let's say that under the void pointer, it's not actually a pointer, but it's an int. I would have to do like whatever array I, which would be a void pointer, but then I have to cast that to an int, which is strange. Or like whenever I would like to push to the array, I would have to do dynamic array push, then my dynamic array, and then I would have to, let's say I want to push an int to the thing, so 42, but then I need to convert this to a void pointer every time I use this function, because it won't do that implicitly, I think. So yeah, it's you can see that the casting everywhere is annoying. Is really annoying. And this becomes even more apparent if you want to store like a struct into it, but like actually not malloc every single struct of your array, which is inefficient. But like if you want to like have a struct, I don't know, position that is that has like an x and yes, I forgot, and a y, like so. Then you want to do like, you would have to do like array at index I, but then do type punning on this, so treat that as an address and then cast that to like struct pos pointer, something like that, I think. And then you have access to like, yeah, and then you have access to x or y, like so. Like, can you see the madness? Can you see the madness? Anyway, it becomes but here with my kind of templating thing in C, where this is actually T. Yeah, I see for sure. Yeah. So, and it's okay if you like malloc pointers to structs for every single one of your elements, but even then, like, even though it would be easier to access it, you would still have to cast the pointers, and doing one malloc per element is super inefficient. So yeah, no problem. But yeah, I did do it once with the void pointers, and it works, you know, and you can learn still a lot from it. But I wanted to do it this way so that the user experience is better. But as you can see, like the implementation, like I have like a bunch of token concat all around, like making dynamic function names and struct names, and you have a bunch of weird macro stuff that I still don't fully understand. So implementation side, it's horrible, but user side, when you actually use this as a user, so for example here, the only thing that you have to say is define dynamic array type to be like an int, and then import the header, then define it to be a float, and then import the header again, and it will like generate all the functions and the struct for you. That's basically what C++ does, except in C++ you don't have to explicitly say that you want like a vector of float, for example, at the top of your program. But I can't really get around with that. But so yeah, at the end it generates dynamic array underscore int, then dynamic array new underscore int, and dynamic array new underscore float, and so on and so on and so on. So you can see that I mean, you still have to specify the type every time you use a function of it, but at least when you like actually manipulate the array and like iterate and so on, you don't have to do ugly casting and so on. So it's something. Anyway. Anyway. I was trying to implement this generic C11 kind of thing into my header, if possible. Wait, no, it's not. It's this one. So I have to say, if this is not defined, let's do an else for now, and if. So if this is not defined, what we do is, let's take up the thing. We define it. We define it to be a generic over, so this is not this is dt pointer, yeah. And you take this. Are you French? Yes. I mean, no, I speak French, but my native language is French, but I am Belgian. And so this is DAX. So yeah, does that work? Let's remove those for now. Unknown type name DT. Oh, why isn't it known? Why isn't it known? I would think it is known. It's strange. Oh, we cannot have a dynamic type there. That's unfortunate. That is unfortunate. You can not have like, this has to be a literal, I guess. Yeah. So expression, no, I won't. Where association list. Type name. Any complete object type that isn't variably modified, that is not VLA or pointers to VLA. Object type. What the hell is an object type? Type voids, basic types. But I guess it has to be that literally, or can it be like a preprocessor thingy? Can you speak German? Ich bin sehr müde. Wollen Sie mit mir kommen? Wasser? Yeah, that's about all the German I know. So, there you go. Generic selection. I guess that's what I was looking at, yeah. Aligners, align of atomic, compound, literal. No, that's not what I want. What are you currently doing? I have absolutely no idea. I'm currently rewriting dynamic arrays. So those are like, in C++ it would be vectors, in Python it would be lists, in JavaScript, I think they're just called arrays. And basically what it is, well, I think there is a better image. It's a struct. Actually, let me show you my struct, for example. So this struct, where this is the type of my dynamic array, which contains a capacity, a length, and the underlying array that actually contains the data. And what happens is, why you have like one capacity and one length, is the length is the actual number of elements, but actually the underlying size of the array might be greater than the number of elements that is in it. And this is done for optimization purposes, so that when you push an element at the end of the array, you might like reallocate new memory for the whole array, but you also might have done in prevision more allocation than what you needed. And so then if you have like, let's say you have a capacity of 10 and you have only 5 elements and you want to add a sixth element, you actually don't need to reallocate anything. And so it's super fast and that's it. But it's better explained with this picture that is on Wikipedia. You see they insert one element, they still have one space available. And then they add one element, but they still have enough capacity, so they can just do it for free. And then you can see here they want to add a third element, but they don't have more capacity, and so they need to do a whole allocation, and so that's why it's slow, but they still allocate more than they need, and so the next one is fast, and so on and so on. I use Linux, Arch Linux, to be specific. Yeah, my config can be found on GitHub if you want. My config is there. So yeah, I think I can give up on the idea of actually dynamically generating a generic function for each of these. Since I cannot have like a macro in the type of the generic thing. Unknown type name dt. And we cannot like define foo is equal to dt, and here we use like foo. That does not work, right? Unknown type name dt. But why wouldn't that work? I'm confused. So at this line, the type dt, unknown type name dt, but I have it all around. Like I have it here, for example. Why can I use it there, but I cannot use it there? So confused. Unknown type name bar. Pasting command dt. Ah, yeah, okay. I'm starting to understand how this token pasting works. It's like it pastes the previous token with the one we have after it. Unknown type name bar dt. So if I do dynamic array of ints, like so, that of course works. Can I do error where dt. Yeah. And there is an info thing. Invalid preprocessor directive. Unknown type name foo. Nice. It's dt then foo. Can I do foo here? I mean, yeah, it will fail because conflicting types for foo have dt. Okay. Because yeah. It's not compatible with any association. Why don't you work? Unknown type name dt. Okay, so it's not because of the pointer. And can I do like define, expand, like so, and I do something like this, where I have like expand dt. And that does not work. Unknown type name dt. Fuck. Is it because of the if and def? Nope. Unknown type name dt. Definition of macro expand. And how about I go back to the top of the file and I use this. Like so. Unknown type name dynamic array t. Fuck me. I don't know. Okay, that does not work. So it does concatenate them, but it treats like t as like a literal t and not like as a t that I defined. Oh, fuck. Alright, scratch that. I should put some notes for future me that this doesn't work. Just whatever. Notes. Using C11 generic doesn't work because wait, works when type is mentioned as a literal. I don't know if calling it a literal is good, but mention manually. Let's take that example. So, but doesn't work with I don't know, variable with type variable. So what I was trying just now. Let's put that on a new line. And I think I can put dt this. Like so. That's a shame. I would have really liked to do generics that way. It would have been fun. Let's remove the junk. Let's remove the junk. I guess we need float there. Up. Let's remove all the junk. Alright. Anything else I would like to do for this project? Anything else? I don't know. But I think if I ever need a dynamic array in the next project, like in some random C project that I do, I think I will reuse this this library that I did, like this implementation at least. I think it's yeah, very handy to use. All right, let's see. What else should I try? So maybe I should add some more nodes for I don't know, anyone looking at this code. A node C11 generic. Nodes on void pointers. Previously done made implementation of dynamic arrays with void pointers, but it was pretty clunky to always have to convert between void pointer and the actual type. For example, let's do the example I had before. I plus 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 and 3, 4 printf f percentage d this, then array I, and you would have to cast to an int explicitly, and then you would have like warnings because they were on the same length and so on and so on, or like dynamic array push into DA42 would have to become a void like so. And it gets even worse. Like I'm gonna take the example I made. I think you can do this, if I'm not mistaken. Where if you want to do array I, then you have to. I'm just gonna do same example that I explain to the guy that asks the question. Strike, pause, pointer, like so. Then you would have to actually take all this and then do X. And so on and so on and so on. Okay. Still wonder why you need one level of indirection here. Like, wouldn't that work? No, it wouldn't. Because it does not replace literality too. Huh. So it does replace that one, but it does not replace that one. Ah, okay. Okay. What else? What else? What else? Yeah, let's maybe just randomly read the Wikipedia page. Bounded size dynamic arrays. A simple dynamic array can be constructed by allocating an array of fixed size, typically larger than the number of elements immediately required. The elements of the dynamic array are stored contiguously at the start of the underlying array. The remaining positions towards the end of the array are reserved. Yeah, that's what I'm doing. Logical size, physical size, yes. Yeah, okay, that's just what I have. I thought it was maybe a different implementation. A fixed size array will suffice in application where the maximum logical size is fixed, e.g. by specification, or can be calculated before the array is allocated. A dynamic array might be preferred if the maximum logical size is unknown. It is considered that a maximum logical size given by a specification is likely to change. The amortized cost of resizing a dynamic array does not significantly affect performance or responsiveness. Actually, I find that in C, for the most part, you actually almost never need dynamic arrays. Like unless it's like a very specific example, very specific cases. In most cases where I had to do like C programming, I could always either like give like just a constant size kind of, or like pre-compute the maximum size of the array. Growth factor, geometric expansion, and amortized cost. To avoid incurring the cost of resizing many times, they make array resized by a large amount, such as doubling in size, and use the reserved space for future expansion. The operation of adding an element to the end might work as follow. Yes, that's fine. That's what I'm doing. As n elements are inserted, the capacities from geometric expansion. Amortized analysis. Growth factor, yeah. First fit allocation. Performance. Amortized just means that like it's constant time, but just most of the time. Like there is it's like a little asterisk that sometimes it takes time. And actually, I don't know, I don't know if anybody is watching. Nope. But if you see this in the replay, like just know that a linked list is almost never more performant than a dynamic array, even if you want to insert at the beginning of it, because of the CPU cache. So the linked list, like all its elements are like all over the place in memory, and so it cannot keep cache locality. But a dynamic array is like just a big blob. So once it has like loaded every single data of the array into the cache, inserting in the beginning and shifting all the elements down is actually not that bad, or faster than linked list, from what I saw on the internet. Variants, gap buffers. Similar to dynamic array, but allowed efficient insertion or deletion operation clustered near the same arbitrary location. Some DQ implementation use array DQs, which amortized constant type insertion removal at both ends instead of just one end. Goodrich. Hashed array tree. Dynamic array. Hashed array tree, waste order, amount of storage space. Naive resizable arrays, also called the worst implementation of resizable array, keeps the allocated size of the array exactly big enough for all the data it contains. Oh, okay. Language support, yes. Come on, Lisp. Alright, it seems to be it. What is NIST? NIST.gov. National Institute of Standard and Technology. vpool. vpool is an auto-resizable buffer, dynamic array use. Using you don't need to care about memory allocation. I wonder how they implemented theirs. So it's just 2 files. Oh fuck, they want me to download it. So they create vpool, then they initialize it. You have to initialize it in bytes. You can expand it. You can insert. Okay, but it's always bytes. It's never like structs or like a specific types. So you would run into those casting shenanigans. Shenanigans? Cannot pronounce that thing. You would run into those casting issues with this implementation. Alright. I wonder what this is. Like apparently they have like an official lists. You should click here to follow the main page. Oh, main heap. I mean, probably cannot read. Monotone priority queue. Yeah, it's like an official list of all the Colucci. Extracted string matching algorithm. Complete graph, computable, conjunction, procedure, algebra. Qsort. Huh. That's funny. What was the Dutch thing? So a Dutch national flag. Wait, what the fuck is this doing here? I'm confused. One algorithm is to have rearrange the element of an array into 3 groups, bottom, middle, and top. And it's called Dutch national flag. What the fuck? One algorithm is to have the top group grow down. Okay, sure, whatever. Some people. Good names. Good names. Alright, well, I think I'm pretty much kinda done with this. Yeah, I think I'll reuse this in the future if I ever need to. So yeah, and I will try to make a video about the simpler versions of this to explain on my YouTube and on my channel. And yeah, that's it.